Hi, welcome to lesson 6.4, the triangle mid-segment theorem. For this lesson, you are going to need a compass and a protractor. You're going to need two pieces of half scratch papers, one glued on page 179 and the second one glued on page 180. On page 180, that's going to be for problems number 4 and number 5. On the next page, you are going to need one piece of graph paper for problems number 1 and for problems number 3. No graph paper needed. And this is on page 181. Pause the video and continue whenever you are ready to go. Now turn to page 179. And we are going to do our first construction, which is the triangle mid-segment theorem. Can't see that. Okay, the triangle mid-segment theorem. So for the triangle mid-segment theorem, the first thing that you are going to need is, of course, a triangle. So give yourself a pretty good sized triangle as shown. By the way, if you hear noise in the background, my 3-year-old is behind me making a little noise. Don't mind him. All right, so what we're going to do first is a mid-segment is the segment that joins two midpoints. So what we're going to do is we are going to construct the midpoint of two of the segments. So let's do for the midpoint of B and C. Open up to more than halfways and draw arcs from both B and C. When you do this, you do not need to draw the full line. Simply align them and mark where the midpoint of that line would be, which is right there. That makes this segment congruent to this segment. And repeat for side AC. I suggest you change the size of the arc so it doesn't get confused with this one. So first, do it from A. And then do it from C. Once you do that, align these. Do not do the line, simply align them and mark the midpoint. That makes this segment congruent to this segment. After you do that, join the segments, the two midpoints, join the two midpoints. So the midpoint of this segment, the midpoint of that segment. If you choose to do the third segment, you may do so. As a matter of fact, that is called the triangle mid-segment, or the mid-segment triangle, you would say. Okay, so we need to pay attention, in this case, to this right here. This is called the mid-segment. Now, we are not going to be able to prove the concepts of the triangle mid-segment theorem because that is going to require us to look into triangle similarity, and that doesn't happen until chapter 8. So we're going to go solely by observation here. Now, I'm going to use my compass here to show you guys what exactly is the triangle mid-segment theorem. It actually has two main things. It has two main pieces of information. Let's start with the first one. Let's talk about the mid-segment in relation to the side, to the third side. If I were to measure the mid-segment, how many mid-segments can go into this? So test it out. 1, 2. Now, due to error, let me see if I can do that again. Should be 1 and 2. So you can actually fit 2 of these segments into here. Let's give this mid-segment a name, ED. So we could say that ED, okay, or 2 times ED is equal to segment AB. Or if you like to think about it, half of the segment AB is equal to ED. For the second part, I need to use my protractor. So for my protractor, what I'm going to do is I'm going to measure angle CED. And approximately my angle measurement is about 65 degrees. So the next one, I'm going to measure angle CAD. And if I were to measure that, I can see that it is approximately about 65 degrees as well. Now remember, this is a construction, so there's always a chance of error. So that means, excuse me, that means that this angle right there and this angle right here are congruent. So if you look at this, these two angles represent corresponding angles and they're congruent. So by the converse of the corresponding angle theorem, that makes ED parallel to AB. Which brings us to the two main ideas of the triangle midsegment. The midsegment of a triangle is half the length of the third side. And it is also parallel to the third side as well. So parallel, parallel, and this is going to be half of this. Let's go over the examples now. Our first example is example number 1. For example number 1, we want to show graphically that the midsegment MN is parallel to JL and that MN is half of JL. So what we need to do is we need to do the distance formula and we need to do the slopes. So it would help if we actually wrote down all of the coordinates. The first coordinates that we have are J and L. J is -6, 1, and L is 2, -1. M is -2, 5. N is 0, 2. So we're going to do two main things. The first thing we're going to do is we're going to figure out that they're parallel. So that means that I need to find out what their each individual slopes are. So in order to find their slopes, we're going to have to use the equation for slope. So if you remember, the equation for slope looks something like this. Differences of the y's over the differences of the x's. Okay, so let's do just that. The slope of JL, differences of the y's, would be 1 minus -1. Differences of the x's, -6 minus 2. That turns into addition to give me a positive 2. -6 minus 2, that's going to give me -8. And that reduces to a -1/4. So the next thing I need to do is I need to find out what is the slope of the other line. All right, so the next part is the slope of line MN. Okay, so we're going to take the slope. That's going to be differences of the y's, 5 minus 2. and negative 2 minus 0. 5 minus 2, that's going to be 3. I actually just realized a mistake. Okay, my mistake is an M. That is not M. I'm tripping here. So that means I need to do this again. I noticed that I was making a mistake because my numbers were not going to be parallel. So let's go back and fix that. So M is actually 2, 4, 3. Okay, so it's negative 4, positive 3. Okay, that was my mistake. Why didn't anybody of you guys correct me? So now we can actually do this again. Sorry about that. You know where I got confused? I saw this number and I thought, okay, it's there. No, it's the wrong number. All right, difference of the y's, 3 minus 2. And differences of the x's is negative 4 minus 0. Okay, so 3 minus 2, that's 1. And negative 4 minus 4 is negative 4. So that means that the slope of mn is negative 1 over 4, which means that they have the same slope, which means that they are indeed going to be parallel. Okay, so what did we just do? We just showed that JL is parallel to MN. The next thing is we need to show that MN is equal to 1/2 of JL. So what do we need to do? We need to use the distance formula. So in order to use the distance formula, I'm going to split this into two pieces. Let's do the distance formula first of MN and then JL. All right, so for MN, let's do the distance formula. Okay, so first is the differences of the x's. Okay, so for MN, difference of the x's is negative 4 minus 0, quantity square, and 3 minus 2, quantity square. So that's going to give me negative 4 quantity square plus 1 square, which is going to give me 16 plus 1, which equals 17. So MN is equal to the square root of 17. And we're just going to leave it like that for now. So now for JL, you're going to do exactly the same thing. For JL, that's the square root of differences of the x's, differences of the y's. So for JL, differences of the x's is negative 6 minus 2 and 1 minus negative 1, which is going to turn into a plus. So that right there is going to give me negative 8 square, 2 square, which is going to give me 64 plus 4, which in turn is going to give me the square root of 68. Now, I believe 68 is indeed going to be divisible by 17. Okay, so if you were to check your calculator, 68 divided by 17, it's actually divisible and it's times 4. So this is the same thing as 4 times 17. I can take this one out, the perfect square 4, and you get 2. So that's going to equal 2 times the square root of 17. So JL is 2 times the square root of 17. Okay, so as you can see here, if you were to manipulate this right here, you don't need to. This right here is half of JL. Hence now we have shown that it is half of that. That's example number 1. Let's take a look at the next example. Okay, in this next example, it says triangles are used for strength and roof truss. In the diagram, UV and VW are mid-segments of the triangle RST. Find UV and RS. So we are looking for UV and RS. Okay, so let's start with UV. UV is easy. Remember, UV is a mid-segment of the triangle, which means that it's going to be half of this. So UV is not only parallel to RT, but it's also half of that. So that means that half of 90 is going to be 45. So UV is 45. Now we want to find what RS is. Okay, wrong color. Okay, so RS, this segment right here, okay, and this is its corresponding mid-segment. So 57 is half of SR, or RS. So RS, we need to, in this case, double that. So that's going to be 57 times 2, which is 114. And of course, can't forget our units. That's example number 3. Example number 4. In the kaleidoscope image, you have AE congruent to BE and AD congruent to CD, and we need to show that those two are parallel. Okay, so let's mark some of these congruent. Okay, AE, that one right there, and BE, this one right here. AD and CD. So now, I know it's a little hard to see. Let me see if I can highlight them. Okay, as you can see, this is the midpoint and this is the midpoint. Okay, so by the triangle mid-segment theorem, DE is going to be parallel to CB because this DE is going to be a mid-segment. So we can state here that DE is a mid-segment. So by the triangle mid-segment theorem, okay, this is going to be true by the triangle mid-segment theorem. And that's it for that problem. Last problem. Okay, so here this involves a little bit of reading. Okay, but before we do a little bit of all the reading, let's find out all the missing pieces of information. Okay, they do tell us that Pear Street is a mid-segment. So that means that this distance right here is going to be 0.7 miles. And because this is a midpoint, this distance right here is going to be 1.3 miles as well. Okay, now just in case we do need it, let's look at the segment from here to here. So half of 2.25 is going to be 1.125. So each one of these distances is going to be 1.125. Now, according to what the problem is asking me to do, it says the following. Your home is at point P. You leave your home and you jog down Cherry Street. Okay, so you jog down Cherry Street, okay, to Peach Street. Cherry Street to Plum Street, over Plum Street to Peach Street, and then up Peach Street to Pear Street, and then over Pear Street to Cherry Street, and then back home. So what is the trajectory that we just took? Okay, basically, we went from here to here, which is the same thing as 1.3 plus 1.3, crossed over this, that's 1.4, went up this, 1.125, and then across here, that is 0.7, and then back up here, which is 1.3. And the trajectory is going to be literally the sum of all of this. So I'm going to go ahead and put that on my calculator. 1.3 plus 1.3 plus 1.4 plus 1.125 plus 0.7 plus 1.3. And my total is 7.125. So this is the exact distance of the trajectory. Please make sure that you have taken up all the notes and have a great day.